What if the biggest killer of the last 100 years was the lie that cholesterol and meat are bad for us? Today, I'm going to dive into one of the most contentious topics in nutrition, the role of meat in the human diet, and we're going to back it up with rigorous science. Is meat an essential part of our evolutionary heritage, or is it actually a dietary relic of our past? Today, I'm going to explore the science that suggests that humans are not only adapted to eat meat, but that meat has played a crucial role in our evolutionary success. We're also going to tackle the cholesterol myth and uncover how we got it so wrong. We're going to start with a fascinating aspect of human biology that always goes overlooked: the acidity of our stomachs. You might think having a highly acidic stomach is just a way to digest food, but it's much more than that. The pH level of our stomachs is a window into our evolutionary past and our dietary adaptations as humans. Stomach acidity is not just about digestion. It's also a defense mechanism against pathogens. The more acidic your stomach, the better you are at killing harmful bacteria that might be present in your food. Now, if you're an herbivore like a cow, you don't need such a strong acidic barrier because the risk of pathogenic bacteria in plant material is much lower. In fact, many herbivores have a more alkaline stomach. This supports the fermentation of plant material by beneficial microbes. But humans are not herbivores. We are very different. Our stomach pH is remarkably low, around 1.5, which is actually more akin to that of carrion feeders like a vulture. So we have a more acidic stomach than most carnivores and omnivores. This is really interesting because it suggests that our ancestors may have relied more on scavenged meat than we previously thought. Consider this: if you're a primate living in the wild, why would you evolve such a strong acidic barrier? The answer lies in the type of food you're eating. If you're eating a lot of meat, especially meat that's not always fresh, you need a way to protect yourself from the bacteria that comes with it. This is where the acidity of our stomachs comes into play. But here's the kicker: not all meat is created equal. The risk of pathogenic bacteria depends on the type of meat you're eating. For example, eating meat from a closely related species poses a higher risk than eating meat from a distantly related one. That's why birds have a very low risk of getting sick from eating insects. And this is also why we see variations in stomach acidity among different animals, depending on their diet and the pathogen risk associated with it. So what does this mean for humans? It suggests that our ancestors were not just occasional meat eaters, but were likely regular consumers of meat, including scavenged meat. This dietary adaptation was probably a key factor in our evolutionary success. Now, this is where it gets really interesting. Maintaining an acidic pH environment in your stomach is really costly. Acidic stomachs should be present primarily in those cases where it's actually adaptive, or where it was adaptive in a recent ancestor. There's two reasons why stomach acidity is so difficult to maintain. One, the host, you and me, must invest significant energy both for acid production and to protect the stomach from acid damage. At the opposite end of the spectrum is a specialized herbivore in which the stomach is designed to have an alkaline chamber, which is basically a pre-stomach, a forestomach, that houses microbes critical for fermenting a plant-based diet. In these animals, an acidic stomach would not have much value at all. One, because the risk of pathogens in their food is very low, but then it also removes and makes it so the microbes that play a critical role in breaking down plant material can't actually live. So with stomach acidity, scholars in general feel that animals feeding on carrion will have the most restrictive filter, as in much higher stomach acidity. The reason for that is that carrion has a really high pathogen load. There's a lot of bacterial growth. Basically, the animal's no longer alive, so there's nothing suppressing bacterial growth. To quote a scholarly article, quote, "It is interesting to note that humans, uniquely among the primates so far considered, appear to have a stomach pH value more akin to those of carrion feeders than to those of most carnivores or omnivores." So we don't actually know when this developed, but baboons exhibit some human-like behavior of feeding and foraging strategies, but their stomachs are generally less acidic than ours. So they don't have the extremely low acidity of human guts. It's basically a pH of 3.7 versus like 1.5. And the lower you are on the pH scale, the more acidic it is. So one of the interesting things is that vegans like to look at gorillas as sort of an example of how humans should eat. The thing is we have completely different gut structures. So it's interesting to try to figure out when the gut actually changed. The diets of like early hominids like Neanderthals and Homo erectus clearly improved in part due to cooking and also in part due to the increased eating of animal products, which were obtained through scavenging, like with the carcasses and stuff, hunting, fishing, and then eventually dairy consumption. In contrast, great apes in the wild derive most of their dietary energy from the fermentation of lower quality plant materials in their hindguts. This hindgut fermentation does occur a little bit in humans, but to a much smaller degree. Now let's talk about evolution. The human brain is one of the most energy-hungry organs in the animal kingdom, and it's no coincidence that this energy demand coincides with our ancestors' increased meat consumption. The reality is the human brain requires a lot of energy to function, and meat is a very dense source of that energy. But it's not just about calories. It's actually about specific nutrients that are really hard to get in a purely plant-based diet. One of these nutrients is vitamin B3, which is crucial for brain development and function. Vitamin B3 is essential for the production of NAD, which is a coenzyme involved in energy production. Without sufficient NAD, our cells can't produce the energy needed for our brains to function properly. So that's where meat comes in. Meat is a rich source of vitamin B3, and it's likely that our ancestors increased meat eating provided the nutrients necessary for our brains to expand. But it's not just about the brain. Meat consumption also played a key role in our social evolution as humans. Hunting and sharing meat required cooperation, which may have led to the development of complex social structures. This cooperation was essential for hunting large game like woolly mammoths, which was a significant source of meat for our ancestors. That's why humans hunted to extinction almost all of the megafauna, or massive animals. Hunting for meat was a crucial step in animal and human evolution. This story actually starts with the Cambrian explosion, which is basically where animals started to become predators, and we see this rapid increase in brain size. This increase in brain size culminated in the 3 million year evolution of Homo sapiens and our overall demographic success, which is why we are on every continent of the world, and also in space. So scholars now actually view human evolution in light of meat intake, and specifically vitamin B3 intake. This actually created this biochemical and immunological switch that affects fertility as well as the immune system. High meat intake also correlates with population stability, whereas low meat and high cereal intake, which is what we got after agriculture, correlates with high fertility, high disease rates, and population booms and busts. Going back to the Cambrian explosion, this is an era that is known as Darwin's dilemma, because evolution progressed so fast. It was essentially a speed race of brain changes and gene changes compared to any other time in evolutionary history. Essentially, we began to get larger brains and mineralized skeletons, which are really important for movement and also acquiring food. All sorts of interesting things likely evolved in this period of time, including more advanced cognition and various other things. It was essentially this evolutionary arms race, as suddenly there were things that could move around and eat each other. So we can actually directly trace our own evolution from this period where being carnivorous actually became prevalent. So we have good evidence, both from archaeology and other fields of science, that indicate that hominids, as in humans and pre-humans, increased meat consumption and developed the necessary stone tools in step with their brains and bodies evolving for this novel type of hunting. And this was at least 3 million years ago when these things developed. So around 3 million years ago, in the Rift Valley in East Africa, we have what we call the cradle of mankind, which is essentially where the climate began to change and there was a reduction in forests. And so our ancestors that lived in trees began to have to discover new and clever ways to get food. And so predator danger was high, but also the possibility of acquiring animal foods was much higher. We began to develop tools that helped us hunt and butcher and essentially reduce the amount of time and energy we spent chewing our food, which also cooking did later. This was a crucial step in evolving our complex social units. So this is why we think that hunting and this development of tools played a really big role in us having the developed social societies that we have now. Because hunting big game was really risky, and to think of ways to ambush it and to butcher it required certain pro-social skills that also involved us sharing this meat across sexes and ages, and clearly played an important role in us developing these complex societies. So our ancestors needed pretty advanced individual and social cognition to essentially step into this evolutionary role that we play, where we hunted megafauna and things like that. Well, adult brains are super metabolically expensive, as in they consume a ton of energy. Our newborn brains and developing brains are actually even more energy intensive. And scholars now realize that it is not possible without animal-based foods to derive that much energy density. So while our remote ancestors were herbivores eating grasses and digesting them in guts, and then we were frugivores or fruit eaters and insectivores or insect eaters, it was only with eating animal protein to supply vitamin B12 and vitamin B3 that we began to actually evolve into what we would think of as an early human. So hominids and early Homo species increased meat intake, but also remained omnivorous, but despite being top predators. So once we discovered cooking, we were able to tenderize meat and make plants, which have a lot of harmful compounds in them often, more edible and nutritionally available, so we could actually eat them. We can also see some culturally learned ways that we made plant compounds easier to eat. For example, there's something called nixtamalization, which essentially allows corn to be eaten. This was something that stemmed from Central America. So nixtamalization actually allows us to get this vitamin B3. And then we developed all these interesting processes of preserving, whether smoking, drying, salting meat, or fermentation, which we did with yeast and lactobacillus. That was essentially how we began to produce beer and also make cheeses out of meat. These all contain vitamin B3 as well. The ability to process milk is something that evolved when we began to domesticate animals. Now, this is super interesting, and if you are plant-based, this may surprise you, but meat is special. In some cultures, they recognize a meat hunger, and it is prized food in all cultures, with cattle often being a primary form of capital and being used to signal wealth or for dowries. Humans take great efforts and go to great lengths to hunt and obtain hunting grounds or pasture land, even through raids or warfare when necessary. The thing is, without our supplements that we have today, vitamin B12 can only be obtained from meat. Even an insectivorous diet where we eat a ton of insects, similarly, iron, zinc, and vitamin A are best sourced from meat. Beyond vitamin B3, there's another thing that we need that is only from animal protein, and that is really hard to obtain if we don't eat animals, and that is tryptophan. Tryptophan is a source of vitamin B3, but it also affects serotonin. And so when we don't have enough tryptophan in our diet, we don't have proper social interaction. So there are several key vitamins that are missing when we have an over-reliance on plants and little to no meat. We need this NAD because it's basically the master controller that allows us to run these big bodies and brains and also restore our stem cells. Scholars have long realized that eating all this energy-dense food was a really important role in apes growing these big brains that became human brains. Our metabolisms actually run faster, which means we expend more energy than chimps or gorillas. And this can really only happen because in our evolutionary past, we increased our mitochondrial function. So the way that we did this was actually by getting more NAD, and that was because we began to eat meat and then to cook meat. In terms of diet, Europe is ahead of the game compared to America on a lot of things. For example, they actually will imprison parents in several European countries if they are found to be raising their baby on a vegan diet. Now, if you are one of those vegans that is trying to raise your cat, a carnivore, on a vegan diet, or your baby, I have some news for you. You actually do need animal foods, even if it's just your own breast milk, to have your baby develop proper intelligence as an adult. There's a low meat eating disease that was discovered back in the day. It's called pellagra, and it causes brain atrophy and subsequent low IQ, dementia, poor social behavior, and a completely messed up gut dysbiosis, they call it. Interestingly, pellagra has actually often been considered something that shows the model of human evolution. When you don't have these animal components in your diet, evolution runs in reverse. It's degenerative. You are Homo without the sapiens, which means wise. Pellagra used to be known as the lazy disease because it was associated with emotional, cognitive, and physical stunting, alongside many other degenerations. Comments about pellagrins as degenerates were made in the early European literature and even more recent American literature, where southern states around a century ago were actually more prone to pellagra. So this led to a situation where there was a lot of clinically undiagnosed cases with impaired IQ, for example, with the average Confederate Army recruit being considered in the moron group. And this was also likely responsible for the notion of the white trash phenomenon, which was a factor that was involved in the Civil War beyond the slavery. Scholars realizing this is one of the things, along with many others, that was involved in the eugenics movement of the early 1900s and late 1800s. Long in the past, this scholar Goldberger proved that pellagra was actually dietary in origin, and it was due to the lack of meat and milk in the diet. It was not something genetic, and it was not infectious. Then in the 1940s, we discovered how to essentially supplement with some of these components in meat and milk that we need. Basically made it so this pellagra thing was no longer a huge issue, generally in the US at least. So let's take a trip back to the ancient past, the Paleolithic era, where our ancestors coexisted with Neanderthals. We are able to analyze ancient bones, and that provides us with a snapshot of what our diets were. So for Neanderthals, we can see that they ate a diet that was really reliant on massive herbivores. For example, woolly mammoth and stuff like that. Now, humans ate a ton of massive herbivores as well. In contrast, humans had a broader dietary spectrum. We clearly ate a lot of freshwater fish. So meat wasn't just fuel for our bodies, it was the catalyst for our social and our cognitive evolution. And one theory is that the reason why we succeeded and Neanderthals didn't was that humans may have had a bit more flexibility with their diets, and this allowed them to adapt to different environments and food sources depending on what was available. However, it's not just a question about dietary flexibility. Neanderthals may have consumed more putrid meat, or as the primal diet people of today like to refer to it as, high meat, which is essentially where they willingly allow some fermentation or rotting of the meat. This could explain why Neanderthals had such astonishingly high nitrogen isotopes, higher than we would have expected, essentially suggesting that they had an even higher protein diet than pure carnivores like wolves, which is pretty nuts. The interesting thing though is these nitrogen isotopes tell us our position as an organism in the food chain. So Neanderthals were at the top of the food chain. They exhibited a higher ratio than hyenas, wolves, and foxes that were found in the same sites as the Neanderthals. One reason for this may be that mammoth meat was extremely rich in protein. Another is that high meat hypothesis, or that Neanderthals ate a lot of putrid meat. Now, something that's pretty shocking is that both humans and Neanderthals were cannibals at some point in our evolutionary past. When humans arrived on the scene in Europe and France, we can see that they even had a higher nitrogen isotope profile than Neanderthals. This is typically interpreted as humans eating a lot of freshwater fish as well as big game. Now, the thing about nitrogen isotopes is that they don't tell us everything about diet. They just tell us about the protein that they consume. So we don't know if they were eating honey, for example, but there are some high protein plant foods in Europe that Neanderthals and early modern humans could have eaten, like hazelnuts. Now, if you are a vegan, you're like, well, they must have eaten nuts. The very remarkable thing is we would see that in these isotopic analyses, and they are not seen. Humans did not actually have almost any protein from plant sources. Now, this isn't to say that Neanderthals did not actually ever use aquatic resources. We do know, for example, that Neanderthals butchered dolphins at some point, and they definitely consumed protein that came from water. But it doesn't seem to have been as important of a part of their diet as it was for early humans. One of the things that I find super interesting is that we have evidence from a bunch of different regions, like Europe as well as many other regions, of Neanderthals, and we can see that their diet is extremely consistent. But in all, one of the things that we have found is that in general, early modern humans and Neanderthals had really similar diets. And we definitely ate a ton of meat as well as marine sources of protein. So this will actually blow your guys' mind, but we have one sample of humans that lived at the same time as Neanderthals in the same place. And what we found is that those nitrogen isotopes are higher than all modern humans and higher than all Neanderthal values. So basically, those ancient humans were eating enormous quantities of meat, fish, shellfish, and all sorts of other stuff. They were definitely not vegan. So just so you guys are clear on this time period, we're talking about 40,000 years ago to around 27,000 years ago. So pre-agriculture. And for the Neanderthals, we actually have evidence from around 120,000 years ago to around 37,000 years ago. So there's a bit of an overlap. In general though, early modern humans and Neanderthals had similar diets and obtained most of their dietary protein from animals. If you're watching this as someone plant-based, you've probably heard of the famous vegan influencers who have essentially said, I'm not vegan anymore, I got chronically ill on a vegan diet, and I've had to incorporate eggs or fish or meat again because I was getting sick. Now, the issue is that they've often based their entire careers on promoting a vegan diet and selling vegan-oriented products. And the crazy thing, and why this feels a bit cultish to me, is that their fans insist that these prominent vegan nutritionists quote, weren't doing it right. Or even more insanely, that there is a conspiracy to undermine the vegan movement. As if these formerly militant public vegans wanted to lose all their income, all their corporate sponsorship, and their fan base. It seems like there's a long honeymoon period in veganism where people feel phenomenal. Then again, most people are transitioning from a standard American diet. As a result, they start cutting out ultra-processed foods and highly processed manufactured foods, which leads to them generally being healthier. Also, as a side note, caloric restriction, which you often get with veganism, does also make you feel better for a short period of time sometimes. Now, after an extended period of time on this diet, the physical and the mental issues begin to creep in. But the thing is, it's not so sudden and abrupt that people instantly renounce their veganism. In fact, most of these vegans ignore their symptoms for months or years as they gradually worsen. So if you were formerly eating a healthy animal-based diet, and then you switch to veganism, you'll have an even longer period of this honeymoon period because you have built up this basis of good nutrition. But waiting till you sink into chronic health issues to return to a more evolutionarily appropriate and nutritionally dense diet is a terrible idea. So one of the important things is that humans can live for, a month or more without food, and you will synthesize cholesterol. That doesn't mean that that's a desirable state to be in, but that the human body is very resilient. The issue with veganism is that long-term adherence to this evolutionarily inappropriate diet, and even a well-formulated vegan diet with supplements, is that it can lead to some serious chronic health issues. Now we're gonna get to a core part of why people think veganism is healthy. This is a really important part of the issue with modern nutritional science. Cholesterol causes heart disease. Now, we know that saturated fats, what's in a steak, increase cholesterol. And so we think that the vegan diet is healthy because it lowers cholesterol. For example, if you watch the documentary Game Changers, they go into the dangers of cholesterol. Now, if you pause it, you'll notice that most of the headlines are from the late 1980s. Now, I'm gonna dive deep into the science and explain to you why saturated fat is not bad for you, and that cholesterol, without what they call metabolic disease, is actually protective for your heart and your brain. The reality is that the world of nutritional science is rapidly changing, and the new research indicates that much of what you and I know about what's heart healthy is flat out wrong. You can think of this like when Copernicus and the astronomers of his day presented new data that overturned the old. But the orthodox academics, as you could think of them, you can think of this like when Copernicus and the astronomers of his era basically came up with new data that overturned the old, and the orthodox academics were having a really difficult time grappling with this new information. So what is the role of saturated fat in heart health? You and I have probably both heard that saturated fat is bad for you, that it clogs your arteries and it'll lead to heart disease. But what if I told you that this advice is based on flawed studies and belief systems rather than solid evidence? Now I'm gonna dive into a series of studies and reviews that have shaken our understanding of dietary fat and cholesterol. So buckle up, because this is going to be a deep dive that is going to blow your mind. Let's start by setting the stage. Where did we get our dietary fat guidelines from? So in the 1970s, the US and the UK introduced dietary guidelines advising people to reduce their intake of dietary fat, particularly saturated fat, in an effort to reduce heart disease. Now, the thing that people don't realize, and that is very alarming when they do hear it, is that in the 1960s, this group called the Sugar Research Foundation literally paid researchers and funded studies with the direction to say, hide the fact that excessive sugar consumption causes heart disease. So these researchers published in prestigious journals like the New England Medical Journal that saturated fat was the cause of heart disease. Meanwhile, they're lining their pocket with money literally paid to them by the Sugar Research Foundation. So the 1970s health recommendations were often largely based on that. There's one other really important body of research that played a role in these 1970s dietary guidelines. This was the work of Dr. Ansel Keys, whose 7-country studies suggested that there was a correlation between saturated fat intake, serum cholesterol levels, and heart disease. But correlation does not equal causation. And as we'll see, the evidence supporting this advice was far from conclusive, like it was made out to be. So in 2015, there was a review published in the journal Open Heart that took a critical look at the data used to create our nutritional guidelines. The study is titled, "Evidence from Randomized Controlled Trials Did Not Support the Introduction of Dietary Fat Guidelines in 1977 and 1983, a Systematic Review and Meta-Analysis." So this study analyzed the 6 randomized controlled trials that were available at the time the guidelines were introduced. And the key finding, that there was no statistically statistically significant difference in all-cause mortality or deaths from coronary heart disease between groups that reduced their dietary fat intake and those that did not. Despite significant reductions in cholesterol levels in the intervention groups, there was no corresponding reduction in heart disease or overall mortality. The authors of the review were blunt in their conclusion. Quote, "The dietary advice introduced for 220 Americans and 56 million UK citizens, given the contrary results from a small number of unhealthy men, seems incomprehensible." That is what the academic study concluded. They argue that the introductions of these guidelines was premature and not supported by evidence. Now, jumping to 2016, a team of researchers re-examined data from the Minnesota coronary experiment, which was this really large-scale trial that was conducted between 1968 and 1973. This study originally sought to figure out if the hypothesis that replacing saturated fat with vegetable oil rich in linoleic acid would reduce the risk of heart disease. The results were never fully published, and the data has only now recently been made available. This 2016 reanalysis revealed that while the interventions did actually lower our serum cholesterol levels, it did not reduce the risk of death from coronary heart disease or all-cause mortality. In fact, the study suggested that replacing saturated fat with polyunsaturated fat may have increased the risk of death in certain subgroups, particularly those with low baseline cholesterol levels. The authors concluded that the available evidence does not support the hypothesis that reducing dietary saturated fat consumption and increasing our polyunsaturated fat intake actually translates to a lower risk of heart disease or death. Now, in 2013, an interventional cardiology specialist, Asim Malhotra, published an article in the British Journal of Medicine titled "Saturated Fat is Not the Major Issue." He argued that the demonization of saturated fat is actually based on flawed science, and that the focus should instead be on reducing our intake of trans fats and addressing the issue that is characterized by high triglycerides, low LDL cholesterol, and small, dense LDL particles. Malhotra criticized the over-reliance on total cholesterol levels as a marker of heart disease risk, pointing out that this has led to the over-medication of millions of people with statins. Going even further back, a 2010 report from the Dietary Guidelines Committee raised serious questions about the evidence supporting our current dietary guidelines. The report noted that many of the recommendations, such as reducing saturated fat and increasing whole grains, have not been adequately supported by scientific evidence. Now, you're probably getting your mind blown by all this, because it is actually mind-blowing that we have been lied to in all these ways. This report suggested that a higher carbohydrate diet may have contributed to the rise in obesity and diabetes that we see today. The authors called for a reevaluation of how dietary guidelines are created, suggesting that the current process may be influenced more by ideology than by science. That's a serious problem. Now, what is the real issue then with our diet? What is causing rates of heart disease and such? Several meta-analyses have challenged the link between saturated fat and heart disease. For example, a 2014 meta-analysis published in the Annals of Internal Medicine concluded that there is no clear evidence to support the claim that reducing saturated fat and increasing polyunsaturated fat intake actually reduces the risk of heart disease. Another 2013 meta-analysis published in the BMJ found that replacing saturated fat with polyunsaturated fat may actually increase the risk of death from all causes. So if saturated fat is not the villain, what is the villain? Increasingly, researchers are pointing to chronic inflammation as the key player in the development of heart disease. Chronic inflammation can damage the lining of our blood vessels, leading to the formation of plaque and eventually heart disease. But there's another big thing that's involved here, and that is called insulin resistance. Insulin resistance is a condition in which our body's cells become less responsive to insulin, which is what we produce when we eat sugar. Insulin resistance is closely linked to chronic inflammation, and it's actually a major driver of heart disease. The reason is that insulin resistance can lead to the overproduction of cholesterol as well as other lipids and to the development of heart disease. A 2018 review published in the journal Nutrients highlighted the role of inflammation in the development of chronic disease, particularly heart disease. The authors argued that inflammation and not cholesterol is the true cause of heart disease, and that reducing inflammation should be the primary focus of our dietary guidelines. So, it seems clear that the old narrative that saturated fat and cholesterol are the primary culprits in heart disease is not true, and it needs to be revised. The evidence actually suggests that chronic inflammation, which is driven by factors such as insulin resistance, poor diet, and a sedentary lifestyle is a much more significant risk factor for heart disease than dietary fat. So instead of reducing your dietary fat intake, you should focus on reducing your systemic inflammation, as well as just living in a more holistically healthy way. Now, this is hard for a lot of people to wrap their mind around. So we just addressed saturated fat. It's been falsely demonized. But you're probably thinking, isn't cholesterol bad? My doctor told me that I was supposed to take a statin because of my blood cholesterol. So let's start there. Cholesterol is a word that strikes fear into the hearts of many. You don't really want your doctor talking to you about your cholesterol. But what if everything we thought we knew about it was wrong? Now, here is a core point. According to the science, cholesterol levels naturally increase as we age, and that there's a good reason for it. So there's a 2016 study titled Lack of an Association or an Inverse Association between Low Density Lipoprotein Cholesterol and Mortality in the Elderly, a systematic review. This analyzed data from 68,000 elderly individuals and found that high LDL cholesterol is actually inversely associated with dying from anything in most people over 60 years old. That's right, higher cholesterol levels are linked to longer lifespans in the elderly. Dr. Ravenskov, one of the study's co-authors, explained that people with high cholesterol live the longest. He pointed out that in numerous studies, high cholesterol was not only not a risk factor for heart disease, but was often protective against it. This finding is a direct challenge to the cholesterol hypothesis, which has long been the cornerstone of cardiovascular disease prevention strategy. So why are doctors still prescribing statins? The answer lies in decades of faulty science and the influence of pharmaceutical companies. The authors of that study called for a reevaluation of us recommending a pharmacological reduction in LDL, suggesting that statins are not what they're cracked up to be. So now we know about blood cholesterol. But what about dietary cholesterol? What about the cholesterol you get in your egg? Contrary to popular belief, dietary cholesterol doesn't have a huge impact on circulating cholesterol levels in most people. The real culprits of heart disease are what they call metabolic disorder, a lack of exercise, and insulin resistance. These factors are actually the strongest predictor of overall mortality and cardiovascular disease risk. So there's a 2013 study titled Dietary Fats and Health, Dietary Recommendations in the Context of Scientific Evidence. And they actually found that saturated fatty acids are not associated at all with cardiovascular disease and are actually beneficial, especially in dairy products. On the other hand, omega-6 polyunsaturated fatty acids, which you probably know as PUFAs, have been linked to inflammation and a host of diseases, including cardiovascular disease. This review was harshly criticizing the replacement of saturated fatty acids with carbohydrates. Now, of course, this goes back to this 1960s misrepresentation of the truth by the sugar industry. This misrepresentation has led to this explosion in obesity and health complications. That's why I said it's possibly the biggest killer of the last 100 years. Now let's go back to an important topic. Veganism. It's a movement that's gained a lot of traction, but is it actually beneficial for you, especially as you age? I think the answer is going to surprise you. Long-term veganism is associated with a host of health issues, including SIBO, small intestinal bacterial overgrowth, osteoporosis, anemia, thyroid problems, and more. These issues often arise from nutrient deficiencies and excessive consumption of fiber and anti-nutrients like phytates and oxalates, which can bind to essential minerals like zinc and iron. For example, the loss of bone density in vegans could be due to the high levels of phytates and oxalates in plant-based diets, which interfere with their ability to absorb minerals. Additionally, the lack of something called conjugated linoleic acid, CLA, and other essential nutrients found only in animal products definitely plays a role. Anemia is a big issue for vegans, and this is usually caused by a deficiency in zinc as well as heme iron, combined with excessive consumption of phytates. Thyroid problems can arise from the consumption of excessive amounts of cruciferous vegetables like cabbage. Not saying that cabbage is bad, but if you aren't getting your proper dietary proteins and nutrients from animal products, excessive consumption of these plant things can actually impact your thyroid levels. So I want to make a really important distinction. It's actually not entirely about the meat. It's really about the essential nutrients found in animal products. So fish, eggs, animal fats like ghee, these can all provide a lot of these necessary nutrients, including B12, NAD, heme iron, vitamin D3, and more. But I also want to make an important point. No human culture has ever been strictly vegan for good reason. Even traditional vegetarian cultures, like the Brahmin caste in India, consume animal fats in the form of ghee, and that's rich in CLA, preformed vitamin A, vitamin D3, cholesterol, and essential fatty acids. Now, this is really significant because a lot of the key vitamins in animal products are fat soluble, meaning they require fat to be absorbed and used by your body. The fat soluble vitamins in animal products are crucial for our overall health, and their absence in the vegan diet can lead to some serious health issues. The data suggests that abstaining from animal products as one ages could have worse impacts than it does benefits. The debate over cholesterol and dietary guidelines is finally beginning to shift, and I think it's time that we reconsider the role of cholesterol and animal products in our diet, particularly as we age. So, animal fats are actually essential for absorbing fat-soluble vitamins like vitamin A. Now, you're probably like, but what about my carrots? My carrots have so much vitamin A in them. Carrots have something called beta-carotene, which is found in plants. And the conversion of beta-carotene to retinol, which is the active form of vitamin A that you need as a human being, is inefficient in many humans. Up to half the population may have genetic variants that make this conversion really challenging. This means relying solely on plant sources for preformed vitamin A can be very risky. The best sources for retinol or preformed vitamin A are meat, liver, beef, chicken, turkey, dairy products like cheese and butter, and egg yolks. My personal favorite. CLA is found in ruminant fats, as in like a cow. Now, CLA has been shown to improve body composition as well as cardiometabolic risk factors. So essentially, it can reduce body fat levels, it improves our glycemic profile, and it can have beneficial effects on cancer and heart disease. However, supplementation with CLA does not provide the same benefits as consuming it naturally with ruminant fat, as in animal fat from most of the animals that we would eat. Another really important thing that you don't get in a vegan diet, but you can supplement with it, is creatine, which is found primarily in animal flesh and is absolutely crucial for cognitive health. So we can synthesize creatine from other amino acids in our body, but this process is extremely inefficient. And there was a famous Australian study that found that creatine supplementation improved working memory and processing speed in vegetarians and vegans. Creatine plays a vital role in brain function, acting as a turbo boost for cognitive processes by regenerating ATP, or essentially our cellular gas, really quickly. Just to hammer home the point, choline is another nutrient that's often deficient in vegan diets, and this is actually critical for neurocognition as well as manufacturing lipids and metabolizing lipids, liver function, and homocysteine regulation. So this is found in significant amounts in eggs, liver, meat, and it's only in incredibly tiny amounts in plant foods. So if you aren't getting enough choline in your diet, this can actually lead to cognitive decline and liver dysfunction. That really highlights the importance of these animal products, especially if you are a vegan and are at risk of these serious nutrient deficiencies. So while a plant-based diet can sometimes be healthy for a period of time, it does not provide all the necessary nutrients that humans have evolved to need. Animal fats and the nutrients they contain are essential for optimal health, especially for our cognitive function and our overall well-being. That's not to say you are unhealthy if you are vegan, but these are really important things to know because the science has been misrepresented for so long. Human health is built on a foundation of nutrient-dense, animal-based foods.